Summit. It's my distinct pleasure to introduce Kostas and Marcelo, who are going to talk about securing Spark applications. Let's welcome them.
Hello. Hello, my name is Marcelo Benzin. I'm here with Kostas Akalis, my colleague at Cloudera. We both work for the Spark team at Cloudera. We're going to be talking about security and Spark applications. So just to start off, like what we talk about when we mean security here. So security has many facets. It can be a process where you have to teach your users about certain things they need to do or they need to not do. It can be a process for the developers writing the application so they don't write security holes into the application. Or in this case, we're going to focus on the Spark side of things, the infrastructure in Spark that can help build those processes. So we're going to be talking about encryption. We're going to be talking about authentication and authorization. So why do I need security in my Spark deployment? So the main thing with security is when you have a multi-tenancy environment, so basically multiple users, in some cases multiple departments using the same data, using the same resources. And you need all the applications running in your cluster to be isolated from each other. So they can't see what each other is doing, they can't access each other's data, and things like that. Also, there's the need to authenticate users so that you can identify who's accessing the data, and you can have audit trails and everything so that you know what's happening to your data. And if something goes wrong, you have a record of what happened. You have access control enforcement so that you know that the user who had authenticated himself has access to the data he's trying to modify or read. And in some cases, some governments have really strict regulations about how to secure your data, especially when you're dealing with sensitive data like medical records or financial information. So before we go further, before you even start thinking about securing Spark, what do you need to do? So in a Hadoop ecosystem, the first thing you do is to set up Kerberos, because that's how security in Hadoop is done. You can use HDFS or any other secure file system. We're going to focus on HDFS here because Spark integrates with HDFS security, and you don't need to do anything in your application if you're using HDFS and you want to secure things. And also, the only cluster backend in Spark currently enabled for security is Yarn. So if you enable security in Yarn, it's pretty easy to get Spark running securely. And then you need to configure Yarn and HDFS you should do authentication, to do encryption, because otherwise there's no point in enabling encryption for Spark. So let's talk a little bit about encryption. So basically, in a secure cluster, you don't want the data flowing over the wire to be visible to anybody who happens to be sniffing traffic. So this is basically very important for people who are dealing with sensitive information, so financial institutions, government institutions, people dealing with medical records or any kind of thing that has strict regulations behind it. So let's look a little bit about what a Spark application looks like from the network traffic point of view. So basically, you start with Spark Submit. If you're running Yarn, you have a resource manager and a few node managers in your cluster. And basically, you're going to start the Spark driver somewhere in the cluster. You're going to run a few executors. And then you start having data flowing in your cluster. So you have control RPCs used by Spark to start tasks, to get results of tasks, to distribute broadcast variables. You have also downloads of files and jars in your application, which use currently a separate channel between the driver and the executors. You have the shuffle and cached blocks, basically the Spark block manager. That's an API between executors to fetch data that's stored in other executors for shuffles or cache data for RDDs. You can also use an external shuffle service, which runs inside the NM. And the executors will be talking to that shuffle service also in that case, instead of talking to each other to get shuffle data. And also, you have physical storage in the node managers to actually store the shuffle data locally. So this is not actually a network connectivity. It's just writing to local disks. And finally, you have the UI running in the driver, which provides information about the running application. So as you can see, there's a lot of data flowing in a Spark application, and all those channels can have sensitive information flowing. So you have input data that is transmitted in broadcast variables, for example, or you have the shuffle data that's written to disk and transferred to other executors. You have, when you serialize a task to run on an executor, it may contain some local information that you loaded from a secure database that is serialized as part of the task. So basically, you want to prevent anybody sniffing traffic in the cluster to see any of those things. So encryption in Spark is supported in almost all channels. The first exception is currently the UI, and the second one is for local shuffle files. For the local shuffle files, you have an easy workaround, which is set up local encrypted disks. But for the UI, currently, there's no workaround. There's some work to enable SSL for the UI, but it's not finished yet. For the other channels, the current state is you have different approaches for different channels. So for the block manager protocol, you have SASO encryption. And for the control RPC using ACA, and for the file download protocol, you have SSL. The problem with SSL is that it can be really hard to set up. So you need the certificates to be distributed all over the cluster because of the way that ACA works. You need them to be readable by the users who are running the applications. And as soon as you try to share a certificate among different users, depending on the SSL configurations, that is not really secure anymore, because the user might be able to decrypt the other user's traffic. And because of this need to distribute the certificates, and also coupled with the fact that Spark's configuration is not very parameterized, it's hard to have per-user certificates right now. So the goal that we have is to enable SASO encryption everywhere, because it's just basically switching a Boolean flag in the configuration, and you have SASO encryption for free, aside from the extra overhead of the encryption itself. It uses built-in JVM libraries, so it's available everywhere. And if you want to track the work being done, that's the Spark Jira ticket. And for the UI, we want to add support for SSL, but we want to investigate other approaches, like making sure that there's no sensitive information being shown in the UI, so that you don't need to actually enable SSL for the UI. That's some work that we still need to investigate and still ongoing. So that's for encryption. And what about authentication? So I want to know who's reading my data. So for that, Spark uses Kerberos. We call it the necessary evil because it's a very nice system, but if anything goes wrong, it's really, really hard to debug. If you've ever worked with Kerberos, you know what I mean. And it's basically the system used for authentication everywhere in the Hadoop stack. So Yarn, HDFS, Hive, HBase, every Hadoop system supports Kerberos. So basically, you want to know who's reading my data. So Kerberos provides this secure authentication system. You have the KDC, the Kerberos domain controller, which is basically two services. The first one is the authentication service. Basically, your user says, I want to authenticate myself with the authentication server, so it sends a message saying, OK, I'm Bob, here are my credentials. And the server says, OK, the credentials are fine. Here is your TGT. TGT stands for Ticket Granting Ticket. And it comes into play when you talk to the second service running inside the KDC, which is the ticket granting service. So now the user has authenticated himself. He stashed his credentials in a local store somewhere. And now all the user's applications have access to that ticket granting ticket. So you run your Spark application, and now the application gets that TGT and tells the KDC, hey, here, I have a TGT. I want to talk to the HDFS service. Give me a ticket. And the KDC says, OK, here's your HDFS ticket. Go talk to HDFS. So that works fine for a normal application. But when you have a distributed application, something like this starts to happen. So you run Spark, and now an executor comes up and says, hey, I'm Bob. And now another executor comes up and says, I'm Bob. And a bunch of other executors start saying the same thing. And the KDC starts to sense that something is wrong, because Bob shouldn't be logging in from so many different places at the same time. And what's going to happen is that the logins will start to fail. So how do you work around that? So Hadoop uses, so basically the KDC is not built for the distributed nature of Hadoop. And Hadoop instead uses delegation tokens. So what happens is that you have, in the case of Spark, the driver, which is going to be responsible for creating those delegation tokens. So the driver gets that HDFS ticket from the Kerberos KDC. And then it talks to the name node saying, hey, I have an HDFS ticket. I want a delegation token that I can use to access all the HDFS services. The name node returns that delegation token to the driver, and then the driver distributes those delegation tokens to the executors. And the executors can then talk to the data nodes using that delegation token, and then everything is fine. The problem with the delegation tokens is that they have TTL, just like every Kerberos ticket. This is OK for most batch-style applications, SQL queries, and things like that. But it's not OK for long-running applications. Like you have Spark streaming applications that must run for long periods of time. You have, for example, the Spark SQL thrift server. You might have long-running shell instances that people just leave around for days. And those do not work well when you have delegation tokens with this TTL. So since Spark 1.4, code was added that allows you to let Spark manage these delegation tokens. So basically what you need to do is when you deploy your Spark application, you give the Spark application all the credentials for your Kerberos user. And then before the TTL of the delegation tokens triggers, Spark will relog into the KDC and refetch delegation tokens from the needed services. And in this case, it only supports HDFS. Right now, this works very well in cluster deploy mode, which is generally what you would use for long-running applications. And there are still some remaining issues that are being worked out for client deploy mode. And now I'm going to hand over to Costa, who's going to be talking about authorization.
Hey. I'll talk about authorization. So Marcelo talked about like authentication, which is like, hey, who am I? We have like encryption, so we don't have users like sniffing data. But now another important aspect, especially in financial and government and companies that have a lot of regulatory requirements, is hey, some users can see some of the data and maybe not some of the other data. So the simplest form of authorization that you may be familiar with is sort of like the Unix style like file permissions. Certain files can be read by certain users, and other files can't be read, and there's group permissions on those files. So this is like a very file-oriented authorization. But there's more than just like file semantics when you're dealing with when Spark reading from data sources that have like tabular data. So for example, data can have multiple columns. Users might be able to, you might want to say, like, look, I have this table of like orders. Everyone can read everything except the credit card column that is the credit card used by the customer who placed that order. But I don't want to duplicate my data, right? I want to have like very fine-grained permissions on the data at the columnar level. There's also use cases at the row level where you say, look, I'm in Europe. I want users in Europe only to be able to see like European records, and I want like analysts in the United States to only see like United States records. So that's like more like row level authorization. So there's a semantic gap here between like file-oriented authorization and like table-oriented authorization. And also, like, to enforce these policies, you need sort of a trusted entity. And with file-oriented on an operating system, you trust your operating system to enforce these access controls. But it's a little different in the sort of the Hadoop space. So, who here has used Hive before? Little impromptu survey. OK, who here uses Spark with Hive to read data? OK, so Hive can enforce some of these columnar level, like some of these security semantics, because Hive is a trusted service. Everything goes through Hive. We can give Hive like special permissions, privileges, I should say, to read all the data and then really filter the data depending on which user is accessing the data, right? This is the Hive Server 2 service that you might be familiar with. And Hive, typically that service is run as the Hive user. That Hive user has like special permissions in HDFS to read all the data and then like do some of the filtering for customers. So Spark is we consider an untrusted app because fundamentally Spark runs as the user that's launching the application. So you can't trust every user, because this is why you have security, right? Spark is not a long-running process that can be run as a user. So it's a little different than like the Hive use case. And this is like this is part of the design of how like Spark works. So this is sort of a problem, and how do we bridge these gaps? Well, there's a project called Apache Sentry, and Sentry is a sort of a third entity that is where you describe your security model, like the policies that you want the system to enforce. And then it's up to the individual services to use the information from Sentry and do that enforcement. Now, with Hive, we can read from Sentry and do the column level security, but with Spark, it's a little trickier because, like I said, it's not a trusted entity, so they can't like just read like Sentry and then enforce those. So what Spark does when it reads data from Hive is it goes directly to HDFS. It reads from the metastore, it goes directly to HDFS, reads the data. We get our nice like data locality that way. But how do you synchronize the two between like the permissions that are available in Sentry and the permissions that are on HDFS? Well, there's this plugin called the HDFS Sentry plugin that synchronizes the two permissions. So if you say, look, at the table level, because tables are represented as files on HDFS, Spark can say, you can define in Sentry, look, this user only has access to this table, as defined by these like files in HDFS. Spark will go and read those, try to go and read those tables from HDFS as that specific user. HDFS will enforce permissions via HDFS like extended ACLs. And if the user does have permission to read that table, then it will return the data. If the user does not have permission to read that table via described by Sentry, then HDFS won't allow you to read the table data. And this is great when you're dealing with table level like security. As I talked earlier, as I mentioned earlier, there's also column level and row level security, which actually is tricky to do because HDFS deals at the file level, and these column and row level security authorization levels that we want are sort of are at the finer grain level than an HDFS file. So you basically can give permissions to the whole file, or sorry, to the whole table, which is the files on this, or nothing. But this still, like today, as things stand today, this is an okay way of like really doing coarse grain like authorization. And then you can set this up today with Hive, with the Sentry plugin, and Spark. So moving forward, to allow column level security and row level security, we really can't do it with Spark by itself. Again, this goes back to the fact that the Spark application runs as the Spark user, and the way that Sentry works is you do need a trusted service. Because as you read the data from HDFS, somebody has to say, no, don't return these columns because this user doesn't have permission, and the Spark application itself can't do that. So we, last month, we introduced this new service called the record service. Alan mentioned it today during the keynote, but it's really a long-running service that works together with Sentry to do the row level and column level and even table level like security enforcement, whereas Sentry is sort of the description of the rules. Record service can actually enforce the rules. So you can think of this as sort of like a nice little marketing diagram. You can think of like record service sort of in between the compute and the storage. We can get MapReduce and Hive and Spark to actually go through the record service and do the Sentry enforcement through the record service. So I'm just going to quickly run through like a little example. But before that, I just want to say that like the record service is sort of meant to be like a drop-in replacement for reading data from Hive and even like non-Hive data. And there's a Spark SQL integration. You can use it as a data source, basically. So if you're familiar with data sources in Spark SQL, it's just another data source that you can like read tabular data from. It also has a non-data source API if you want to use that. And there's also like Spark SQL integration where you can create temp tables in Spark SQL. So it's really meant to be like a low friction way of like doing some data access. So after you read the data in Spark, then you go off and do your Spark processing. So I'm just going to quickly run through this sort of little simple example. So let's say we have this like TPCH like table, the nation table. There's a nation key, a name, a region, and a comment. And we want to read this table data through Spark. Well, using the record service, you would do it in such a way, in sort of like this way here. So you'd import the record service, and then when you load the data, and the stuff that I've bolded is what's sort of like specific to record service. You'd load the table, you specify that it's a record service type in your data source, and then you go off and do the rest of the stuff. Here we're like grouping by like the key, we're doing a count, and then collecting. You can do other stuff. And this is fantastic, and it works well. And this is no different than if you were just using straight up like Spark SQL to read data from Hive, and you wanted to enforce table level security. So let's say we didn't want any users to have access. We didn't want specific users to have access to that nation table. We could have done that before, and record service doesn't offer anything more. There are some performance benefits to record service because it's running like the Impala like scanners underneath, which are actually very efficient at reading data from disk. Other than the performance improvements, there isn't as much. There isn't anything more you get here. Okay, cool. So let's say now we want to. And sorry, getting back to sort of the previous example, I forgot to mention the one thing you do get for free is that if in Sentry you specify that, hey, I actually don't want a certain column, like I don't want the region key to be like red, then you would actually get a permission denied error here. So you'd say like you get an authorization. Actually, you get an authorization exception. So if you set up Sentry like saying specific columns are not viewable by certain users, then you get that for free for record service. Now, let's say you wanted to do row level security, right? You only want certain views. Well, what you can do is after you've set up like your roles, and this is sort of how you do it in Hive, you create like a role, and you can create a view that's basically like a sub-select of like the table. Let's call it here like nation names is what I called it, and then you assign like permissions to that role. Well, you go back to like the code again. If you try to read that nation table and you don't have access to like the specific rows, then you will get this kind of exception here. And if we change this to the view that we do have permission to read the data, this will like succeed. So it's sort of like creating views, and then record service will enforce those views depending on the user. This is how we feel like we can get row level and column level like security inside of Spark. Today, like I said, the record service is in beta. You can download it, you can use it, it's open source. And we're working on, the community, I should say, is like we're trying to build a community around it since we just released it, and trying to get it to like become GA. If you don't want to use record service, the authorization, like I described, which is available, is like table level security using Sentry and the HDFS Sentry plugin. That's available today. You can use it. This is sort of like the future. If you want more information, there's documentation. There's a beta download. Contributions are welcome. So some takeaways, like you can make Spark like secure today. We are working on trying to make it, the community's working on trying to make it easier with the SASL encryption, which will be sort of like a flag to turn on, and you get encryption everywhere for free without dealing with like TLS certificates. But there's still a ways to go here with getting like better security and ease of use. Here are some references. These are the tickets that pertain to the work, the encryption work that Marcelo was talking about, and like the record service link. I think that's it. Cool. I think we have a few minutes for any questions if people have any.
I'm imagining key management in this distributed environment to be a total nightmare. Is this a correct feeling?
Yes, key management is really hard, and that's why we want you to kind of move away from requiring SSL as the encryption layer. With SASL, you don't need to manage any keys. Basically, there's the authentication step that is done. And the authentication mechanism used by Spark allows for encryption. So basically, the key is negotiated on a per socket basis, so you don't need to deal with key management at all. If you're talking about key management for HDFS encryption, that's a completely separate topic. We can talk about it as much as we want, but that would probably be like another 30-minute talk.
Yeah, and I mean, Spark benefits from the fact that it's like a closed system, like Marcelo was saying, so you can just generate keys and use those as your encryption keys.
How do you do intrusion detection? If it's a closed system, you should be able to detect an intruder, but on the other hand, as you are using cloud-based platforms, you've no idea if you have got a spoof executor somewhere in the system.
So if you enable authentication for your application and you have everything set up in Yarn to be using encryption and everything, there's no way to have a spoofed executor because that spoofed executor would not have access to the secret needed to connect to the application.
Great. One more question? Sound good?
Since record service sits in between the compute engine and the data store, do you think it's going to have a performance hit when the actual computations start?
So there is a specifically for the record service. There's a whole other like kind of talk about like the record service itself. From experiments that we've run, because the record service is using like the high performance like Impala like readers, it's written in like native code. It actually is very efficient to read data from disk. So that the performance improvements you get with the record service sort of offset some of the performance like penalties you get with doing like inter-process like communication. Now there's a record service process on each machine, so you really are talking about the IPC costs. But yeah, we've seen like depending on the type of workloads that you run, we've seen actually improvements in performance, even with the IPC costs. But again, this is like there's a whole other like kind of conversation about record service itself in terms of the performance that we don't have time to get to right now.
And I think they'll stick around if you've got more questions. Yeah. Let's thank our speakers.